All right. Thank you everyone for joining. This is kind of the first call for Fabric. Just to give people context, late last year we started a series of calls to focus on the L1 components before Fabric was really a thing and have rolled that into Fabric. And so this is a kickoff. Uh, Not everyone that's part of Fabric is on, just kind of the diehards, I guess. I learned a bit from Justin to make sure the call is as positive as possible. So I expect in later calls we'll have more people join, more L2s join that are maybe a little more skeptical, but to learn along the way and provide their feedback around that. Um, just a little context too for Fabric. People have probably heard of this, but really the goal is to create a space for collaboration, but also support development work and standardization to push base rollups forward. We want to see as many base rollups in production as possible, so we don't want to slow teams down, but just stay along with them in the process and help push certain areas where we know various teams are aligned or could align or slightly unaligned. And if they align, it'd be much better for the ecosystem. And so that's really the main mission and goal of what we're trying to do here. Um, We'll probably do these calls bi-weekly because we do have a packed set of agenda. We wanted to get enough in place that we have at least a few weeks. So a couple weeks out, we'll have a call and we already have pretty much a packed thing. But if there's anything people want to discuss, just let us know. Um, yeah, so with that sort of administrative stuff out of the way, Chris is going to talk just for a couple minutes on an event they have coming up where it could be a Schelling point for based rollups and sequencing generally. And then Jason will start going through things. So Chris, over to you.
Cool. Thanks, Drew. Can everyone hear me? So yeah, a lot of you already know Superlin. So Superlin 2025 is back, and some of you already been part of Superlin 2024. There's been a huge selling point. For example, the first pre-conf DevNet was launched there, and we're back this year with even more content density and some improvements. So we have a much nicer place this time, a whole boutique hotel with co-living, so most of the people can actually stay and live on site. And we're planning our content and the programming much earlier this time, so it will be like earlier announced and a bit more structured. So some of the things that are already happening is we'll have L2 interop days co-organized with L2 Beat, Espresso, T1 protocol, and most of the big L2s will be there. We'll have a cryptography day with Aztec, PSE, EF people, Starkware, Succinct. We'll have stuff on protocol architecture with EF people like Dankrad, Ansgar, etc. We'll have data workshops with Dune Flashbots and a lot more. So we're keeping it still a bit under the radar because there's so much incoming interest. We haven't publicly launched it, but we'll go more public soon, and we're exclusively sharing it now with this group. So the dates are June 13 to 22nd. So it will be during Berlin Blockchain Week, right after Protocol Berg, and also integrated with DevCon. And so if you're interested in being involved or joining, I'll share the link here. Superlin.city is the domain. Just put in your email, you'll get a notification when application opens early April. Or if you want to get like even deeper involved, just send me a Telegram message. I'll also share the link here. And then, yeah, happy to see a lot of you there again and making another Schelling point. And yeah, get the whole Fabric ecosystem more rolling with all the L2s.
Sweet. Awesome, Chris. Thanks for sharing. Yeah, fire those links over. And yeah, last year it was a great event, good Schelling point. So I encourage people to consider it. But yeah, so with that, I want to turn it over to Jason, where we'll start the agenda. If you want to see what's in place, it's in the invite, plus I sent it through the chat group yesterday. Nethermind will also be going through quite a bit. So again, it would encourage teams if they have things they want to present on or research they want to talk with the group in future calls, just reach out. And that's the intention. So Jason, over to you.
Thanks, Drew. Let me share this. All right, can you see my screen? Good, cool. All right, so yeah, the agenda, I was gonna go over the roadmap kind of more briefly. I think everyone's had access to the document, but I'll try and just zoom into each of the components and give a little high level overview there. And then really talk about Dido. This is like a potential research proposal on how we can modify how we do inboxes on contracts to make them more base sequencing friendly. So I'll try and spend most of the time on that. So if you haven't seen this this diagram on the right-hand side here, these are kind of all of the components that we were trying to focus on with the Fabric effort and really focus on what are things that really fall through the cracks or don't really make sense for a single protocol to spend all of their efforts on. The ones that made the most sense were around like constraints API, everything L1 related are things needed by based rollups, but not really in any single person's best interest to make. So we're trying to focus on the public goods. And on the left-hand side here is kind of the ordering of the priorities, and I'll go over those right now. So the first one, commit boost started way before this, but really, what is it? We need some way for validators to be able to make these commitments. So commit boost is a sidecar that runs alongside your consensus client and allows you to sign off on new commitments with your validator key. And it's really meant to be this like platform for people to build on top of. It's not really enshrining any specific logic here. But I think the big news is like, I think it's around 7%, maybe correct me if I'm wrong, Drew, the validators are on mainnet using commit boost in production today. So some of the next steps will be how can we modify like the PBS module or like add a new type of module to work with these pieces that we're working on. Okay, the next piece here is around education. So the kind of goal here is we want to make this research and knowledge like accessible to everyone. It's really a rabbit hole. I think most of the people on this call have gone down that rabbit hole, but we want to make it easier for people. So we have a couple of sites up right now, and I think you can just click from this PowerPoint, and we'll take you to a bunch of links on pre-comps, on based rollups, as well as some high-level explainer series on like what based rollups are. I think one goal out of this would be for people in the space to agree on some of the terminology, because I've had conversations where we're always talking about the same thing and we don't realize it because we're not all on the same page there. One of the next things that we'll shoot over in the next week or so is around composability. It's trying to cover all of the different properties that you get from shared and base sequencing to also try and align the Fabric roadmap. Like if we want to achieve these properties, what do you really need to modify in a rollup stack? Okay, moving on here is the constraints API. So we've had several working group calls following from DevCon, and the constraints API is extensions on top of the existing PBS architecture that allows for proposers to add more constraints to the block building process. So now when they make their get header call, they're able to not just blindly sign off on a block, they are able to verify some proofs that their constraints were satisfied. And this is one of the prereqs that we need to do arbitrary proposer commitments, including pre-comps, of course. So the status is that the spec has essentially been finalized. There's just one outstanding PR that needs to be merged in. And then what we're really hoping is for teams to start building out reference implementations. And this would kind of take the form of like one of these modules on the sidecar. Sort of the companion of the constraints API is the Universal Registry Contract, or the URC. The purpose of this is to add accountability to these proposer commitments. So there's a way to register your validator keys on-chain and post-collateral, and you can be slashed if you break a commitment. So the spec here is also essentially finalized. We're just kind of at the optimization point right now, and then aiming to get audits out really quickly. So the kind of next steps here is there were a lot of design decisions made with the URC to minimize the on-chain gas costs to make it more feasible for people to use. Like we don't want to save everyone's validator keys in storage on chain because that's really expensive. So the URC is going to need some indexer running alongside it so you can know the latest state. And ideally, that's like an open source indexer that anyone can run. And similarly, you need to actually interface with the smart contract, whether that's through some kind of GUI or CLI. I'm sure many teams will have their own ways of doing that, but having like an open source version would be great. So the next one is the commitments API. This is up and coming. We're going to kick off a working group on this really shortly. The idea here is we need to define like the schemas for what like an actual commitment looks like. So this kind of summarizes it. If you take a pre-conf request, how do we turn that into a signed commitment from the pre-confer? And ideally, we want this to be generic and future-proof enough where we can handle arbitrary types of commitments as they come up. So we've been in contact with a lot of the pre-conf teams, and I think there's already some rough consensus on what schema would look like. We just need to really iron out the final details and put together the spec. Okay, so the look ahead. As we start to go down this list, we're moving away from just the L1 block building side of things, and we're starting to enter like territory of how do rollups do their sequencing. So things could start to get a little more contentious, but bear with me here. So the beacon look ahead, this is like we know ahead of time what the schedule of the next validators are going to look like. And if we want to go beyond total anarchy mode for based rollups and allow for like more sophisticated scheduling to enable things like execution preconfs where you need to guarantee a write lock ahead of time, we're going to need to make the based rollup aware of the look ahead window. And there's proposals. Nethermind and Open Zeppelin have contracts implemented for this. There's also what I'll get to later in this talk is Ditto is this idea of can we do it all off chain and avoid the L1 at all costs. So the next steps here, definitely another next step is there's a potential that we can all work together and produce an EIP for this that would expose some view of the look ahead at the execution layer, but that's kind of way down the lines. Definitely the shortest term thing would be some kind of smart contract that does this. One of the issues though is that there are lots of gas cost issues and incentives around posting this look ahead window view of the window to a contract, which inspired some of this research. Okay, blob sharing. I'm gonna just gloss over this because really Nethermind is trailblazing on this one. But the whole concept here is we want multiple rollups to share a single blob. And this is extremely important for based rollups because they can't do as much gas cost amortization as a classical rollup could, who can post at any frequency that they want. If we're posting blobs very frequently, we need the costs to be shared between rollups. And also this is a great first step for some of the composability guarantees we want. Like when we have a shared sequencer, we want them to be able to post a single history for those rollups, and compacting that into a single blob really helps. Great. Okay, inbox. So now this is where we start to transition into like what the Ditto research is. But first of all, what is an inbox? It's just the name of some place where you submit your blobs. And each rollup has a different implementation of this. For example, like in Tycho, there's a contract you post to. On the OP stack, it's just an arbitrary address that you send the blob to. And you kind of, in the OP stack case, figure out if the blob is canonical or not during L2 derivation. And that was kind of the motivation for this research is if we want to allow based rollups to have kind of like the validators as sequencers, we need to try and like come up with a simpler way to figure out like who's actually like what blob is allowed. So just for comparison, on the OP stack, they check the signature on the blob transaction and make sure it matches that of the canonical sequencer. The idea with this Ditto research is like, can we do that same kind of check during derivation? Was this blob posted by maybe a pre-confer that was registered to the URC with sufficient collateral? They were the next validator in the look ahead. Like all of these conditions must pass in order for the blob to be considered canonical. And we'll now kind of dive into what does that really look like in an implementation. And so this picture is really tiny on the screen, so we're going to dive into each piece kind of step by step as we go through this. But some disclaimers, like definitely this is a work in progress. Terminology, again, like we all need to agree on terminology, so it's subject to change. And there's some sections, mainly this one here, that are somewhat idealized and definitely contentious. So maybe a request here would be to save questions for maybe after I get to the end of these slides, because for the people watching this over, it could be a little cleaner if I go sort of step by step without interruptions. So, all right, diving right into it. So this is where the constraints API comes into play. And you'll see a couple pieces here. So the L1 proposer is using some kind of sidecar like commit boost, and they would register to the URC. And this is an on-chain transaction. And the URC supports batch registrations. They can add many keys at once. And they're going to sign an off-chain delegation message to grant constraints submitting and commitment submitting rights to a third party, which we call the gateway. But the big important thing to remember here is this is entirely compatible with self-delegation. So it could just be like we rename this other box to be also the L1 proposer. All right, so what's happened right now, the L1 proposer has registered on chain with the URC, and then they've delegated constraints submitting rights to a gateway during their slot. And this, again, is happening off-chain. And this was also an important design point for both constraints API and the URC, was to have off-chain registrations for or off-chain delegations to minimize switching costs for validators and prevent vendor lock-in for many specific proposer commitment protocols. So, okay, now this is where things start to get interesting. We'll take a look from the top down. So let's say you're an L2 user, you want to submit a transaction. Maybe the ideal case, that transaction would go through what's been called an RPC router and put in some public mempool that can be drawn upon from different L2 nodes. And these nodes would be run by what we would call L2 builders, name subject to change. But of course, realistically, there's going to be some private order flow, and it could just be a simpler path directly to the builder. And the idea here is that these builders can horizontally scale to service as many rollups as they want. The goal in this kind of design here is we want to minimize gateway sophistication. So let's say L2 builder A here now has a cross-chain bundle. They would use the constraints, or sorry, the commitments API to actually post that to the gateway. And it's the gateway's job to figure out that mapping from their commitment into a constraint to pass back down to the L1 supply chain. But from the point of view of like the builder and the users, as soon as the gateway signs the commitment, like that is the pre-conf that they're getting back. In this case, maybe the pre-conf would be like, I will include your cross-chain bundle, or I will include your blob at any kind of level here. The API will be flexible enough to support that. So this part right here is where the whole Dido idea comes into play. So the proposal is that the gateway would be able to determine what the actual look ahead is and prove that. We can do that all off chain. Like this would be, instead of having some kind of on-chain view of the look ahead. And they can also do storage proofs and figure out like, was the proposer actually registered to the URC, get all of this proof data for both the look ahead and the URC, and compact all that into some metadata and attach it with your blob. And what's happening here is the gateway is going to post a constraint that says, I want you to include this blob. So this is where we kind of enter back into the standard or L1 supply chain, but with the changes from the constraints API. So the relay is going to run the auction. Builders are going to function as normal, except that they have to include another proof with their block headers that satisfy the constraints requested by the gateway. Once they've built that block, the validator is able to call this new get header with proofs endpoint, verify the constraints, and submit the block, or submit the block, I guess. And part of that would be this blob transaction, which would update the state of what we're calling a universal blob inbox, also subject to change. This would just be like a shared inbox that other based rollups can post to. Okay, and now the final step here would be back to the L2 state derivation. So this inbox is going to be receiving these shared blobs. It can unpack those and verify the proofs that had been attached in the previous step. So it can check like the L2 node and derivation would check like, were they part of the look ahead? Were they part of the URC? Were all those boxes checked? And if that returns true, then they can proceed with kind of the standard flow for that specific type of rollup. So, or like their specific VM, their specific proofing system. It's not really kind of what Fabric is trying to work on here. It's more about how can we allow for base sequencing to kind of happen more smoothly. All right, and that's kind of the overview. Maybe I could open it up back for questions. And beyond that, there are some like burning open questions here. So there's some issues with this design in that at blob submission time, you don't really know what the latest state root is of the URC. You just know it from the previous block. That actually isn't a big problem for this because the expectation is that there's going to be some kind of entry and exit buffers for opting in and opting out of the URC. So a 1 block delay shouldn't make a difference there. I think that this problem, though, kind of keeps coming up as we start to get into real-time proving and other kind of parts about composability. The other problem, which I'm going to hold off on, and I think Lynn will talk about, is there's kind of an issue with the look ahead in the picture update, which I'll see for him. I see question, Tom?
Yes, thank you. So I think this is great. I really think this is the right approach to do the as much as possible off-chain and make the on-chain footprint minimal. So just curious, like, I guess one question would be, is this contract, if it's even a contract, I guess it'd just be an EOA, like Optimism, is there going to be configurability or governance? And then that's connected to another thing of just typically these systems, I believe, have at least some minimal contract side validation. Like, for example, how do you prevent, 2 submissions for the same L2 block? And maybe there are ways to allow that, but typically that's been prevented. So if there's going to be that type of minimal validation or broader validation, how does the governance work? And just what are your thoughts?
Yeah, so I think definitely some kind of spec is needed for this kind of universal blob inbox, and maybe the Open Zeppelin team could also chime in. I think they've been thinking about a design like this. I would say it would be as minimal and governance free as possible. Like if this was a shared inbox, I think when it came to validity proofs, you needed an on-chain reference to the blob hash. And so that seems to be like one of the only requirements is that when you post to this inbox, it will like store the blob hash. And that can be kind of how you, I guess for your other question, like multiple people submitting at the same time for the same rollup, I think that can also just be handled off-chain as well. We're kind of saving these references.
Totally makes sense. Last really quick question. Will this be an upgradable contract or not?
I would say no. Yeah, still needs to be spec'd out, but I would think like for something that simple, it should just emit a hash. And I think the thing that would be upgradable is like different rollups can choose in their full node configurations, whether they actually view this inbox as like the canonical address or not.
Thanks.
Yeah, Gustavo.
Yeah, Gustavo from OC here. We've been playing with this as well, and one constraint with fun and why we today at least we have like a single inbox per rollup is that you also sometimes want to include metadata, like in the type example, for example, you want to have like the anchor block for what is the latest L1 block that the L2 sees. But I think if we solve all the other things, this could be overcome by just doing hooks. So the universal inbox contract could call arbitrary contracts, and just the builder can make sure that those calls succeed. So like when they pack everything, they would simulate that before and make sure that succeeds. So that is an idea that we could experiment with.
Awesome. Well, maybe I'll leave it back on the open questions, but I guess if there aren't any burning questions, we can hand it over. I'll hand it over to Lynn, I think, is presenting.
I just had one question. Especially at like Buffer, we already have an existing registry contract. For pre-comp. We're actually following sort of the pathway that Kubi like laid out in one of the research quotes, where like this is the pathway to becoming based, and that AVS or the smart contract and eigenlayer is part of it actually. I'm curious if there is any roadmap of how to make such contracts compatible with the URC. I know that other teams are also working on their own contracts on these restaking protocols, so like that's something that I'm curious about.
Yeah, good question. So one of the design choices from the URC was to not enshrine kind of any logic about slashing in it. So to be as generic as possible. And that also meant not enshrining any like restaking protocol into it as well, which come with their own slashing logic. So with the URC, what you can do is kind of call into your like eigenlayer AVS to do the slashing. Like the real requirement here is that pre-conf protocols are going to have their own slasher. It just has to have the same slash interface. And when a validator breaks their promise, you call slash on the URC, and that calls slash on your self-defined contract. So it can plug in nicely with all the existing restaking protocols.
I have also a question. I'm from SSV, Moshe from SSV. So we are also building based on what Fabric will do. We are building a distributed validator. So we already have it right on mainnet. But the only problem is that when the validator is distributed to multiple nodes, right? So it needs to know that the block is valid. So it needs to see the proofs across multiple nodes in order to vote on it, right? We have a BFT mechanism. So we need to see the proofs. We need the proofs to be exposed outside of the, publicly to the proposer, I guess, for that. So I would like to know what you think about it.
Yeah, so that'll definitely be compatible. Like from day one, we're also trying to make sure that DVT was supported here. And so one of those decisions was requiring that delegations are signed off with a validator key. Like we tried to keep BLS keys in the design, even though they are not friendly to the on-chain side of things. So in that sense, it's compatible. I guess what you're getting at here would be when you call get header with proofs, each of the validators in your cluster would call this getter or get.
Right, exactly. So imagine that like there's one leader that today with MEV Boost, there is one leader that gets the block header and he proposes it to the others and they vote on it. And when there will be commitments in the block, then it will also need to attach the proofs, right? So the others can validate before voting. So that's my concern, is that currently in the design, the get header with proofs does not expose the proofs to the proposer, right? It kind of validates the proofs and exposes only get header to the proposer, as far as I know today.
So it actually does. So I would recommend going into this.
Yeah, the relay does, right?
The relay returns the header with the proofs, and then so you can read it in the specs here, but they have the proofs attached to it. So if your like leader node also broadcasted that to the other nodes, then they'd be able to all verify the proofs independently.
Right. So we will need to contact the relay directly, and instead of like using commit boost or one of the modules, right? Most likely.
Well, in this, back to this picture, so the proposer is like assumed to be using something like commit boost in order to, like commit boost has a PBS module inside it, so it's kind of like modified. You'd run modified mev boost with the proposer here.
Right. So I guess this is like a concern for the commit boost and the I guess the modules, right? To have it exposed to the proposer, because they contact the relay which exposes the proofs, but they don't expose the proofs to the proposer in the current flow. I mean, as far as I know. But thanks. So we'll keep checking it.
Also, another DVT related question, this is also from SSV, because now we have like, four nodes, for example, and they each make the same call, get header with proof, for example. What configs do we have if they get the same result? Because
hey, Gal.
Sorry.
Yeah, it's hard to hear you.
Okay, really, 1 second, let me disconnect my headset maybe. Is it better now?
Yeah, still kind of hard to hear.
It sounds like reception connection is slow.
1 second, I have some issues here with new headset. It doesn't turn off.
Yeah, you can write in the chat in the meantime, Gal.
Yeah,
until it's fixed.
Now it's better.
One question.
Yeah, now it's better.
I was just trying to ask this guy from Mrs. V. Sorry for the little technical mix-up. So pretty much my question is, suppose now we have 4 nodes, and they're each calling get header with proofs, and they work with a certain gateway. Could it be possible that like the gateway also works somehow with different relays, and maybe like each node will get like a somewhat different answer? Like what guarantees can we have regarding consistency? I'm just wondering if we also need to run some consensus inside our DVT cluster.
Right. So one of the constraints is that there's only one gateway per slot. And the proposer, like the relay is the one running the auction. So like this should all function exactly as it does today with MEVBoost, except the payload that your sidecar gets back is going to have like this extra proofs field. And the expectation is that your sidecar implements the logic to verify that. But the flow is, yeah, the relay is no different in this really as a job than in current MEVBoost.
Yeah, I was just wondering if like gateways could work somehow with different relays and somehow we'll get like different answers from each instance. That's my only worry. But okay, I think you said one gateway, so I think that answers it. Thank you.
One more quick question from Alan, also from SS Relay. when you say we can get also the proof of the blocks, we also have a list of commitments for along with the proofs, right?
So what you have are a way to get the constraints that were issued by the gateway and the proofs. Like the proof, like the constraints API doesn't really know anything about what a commitment is. It just deals with constraints. There's some mapping that has to happen. Like if you're creating your own commitment type, like you need to define somewhere like how is a commitment actually mapped back to a constraint. But the proposer itself won't be exposed to like, and the relay won't know what the actual commitments were. It's up to like the user. In this case, the user can slash the validator if something was broken because they have knowledge of the commitment that was made.
Oh, okay. So maybe I mixed up a bit the constraints and commitments. So for a proposer to really verify the proof, it has to know the list of is it constraints that you mean I mean what they what was included, the transaction that are included in the block.
Yeah, to verify the proof, you need access to the constraints and the proofs themselves. And you'll use the constraints as input when verifying
Okay.
the proofs.
Okay, I see. Thank you.
Well, okay, I think I need to hand it over to Lynn now before we run too close to the hour. So thanks, guys.
Okay, let me share my screen. Can you all hear me first? Okay, wait, can you guys hear me?
Yep.
Okay, cool. Okay, thanks. And you can see my screen.
Yeah.
Okay, cool. So yes, today, yeah, I'm Lin from Nethermind, and I just wanted to share about what we've been thinking about around look ahead for pre-confs. And first, some background, like on like why look ahead is important. Like maybe it's clear for everyone, but just to be on the same page. In pre-confirmation protocols, like usually the next opted-in proposer, so like the other proposers, these like these proposers with like the red filled in the background, these are the pre-confers. And the one with the dashes, they are non-pre-confers, so they're not opted in. So like usually in a pre-confirmation protocol, like the next opted-in proposer will be elected pre-confer for the given slot. So you look at the look ahead, who are the upcoming proposers, and you say that, hey, the next opted-in proposer is this guy, P7. So this is like the next opted-in proposer. So like they're going to be the pre-confer for like P4 and all. Okay, and like how we exactly use this is that at least in our like POC implementation for Tycho, like we in the batch inbox contract, we limit the batch submission to the pre-confer. And there's possible alternative to this that we can discuss later, and also like Jason covered. But so what it looks like is in the proposed batch function, like you call in like lookahead dot get next pre-confer. So there's like some lookahead module that you can call into to get the pre-confer. And you check that like the entity calling the proposed batch is actually the pre-confer. Now the big question here is like, how do we implement this module? And why this is even hard in the first place is that in the EVM, only past proposers are visible via the beacon route. The current and future proposers are not accessible because the beacon route itself is not accessible. So when you're at slot 4, like all these slots, you have like the EVM itself like has no idea who the proposers are. You can only know who the past proposers were. So like the big question is like, how do you make this visible to the EVM? And yeah, our Tycho POC design, like what we did is that we say that, okay, to make the look ahead visible, like you have someone like post it to some L1 contract. And who actually posts it? We say that the first preconfer of the epoch like optimistically posts look ahead for the next epoch. So in this diagram, like this in slot number 1, let's say that this is a preconfer, so they are gonna like preconf and submit something to the L1. And when they are submitting their like L2 batches, the preconf batch transactions, like this also submits the look ahead of the next epoch. So like this whole part, like they can calculate it based on the current roundout and when submitting their L2 blocks, they like post the look ahead to the L1. And this is optimistic because like at this point, the L1 is not aware, or like the EVM is not aware what this look ahead is. So, but what we can do is like it's optimistic, and later on, like when this whole epoch ends, you can retroactively slash because like you can look at the past proposers and see who were actually the proposers, and like slash if the submitted look ahead does not match the proposed in the beacon root. So there's like an optimistic design that we took. Okay. Okay, like this is like what we had before, and like next I wanted to share like some of the kind of issues that we've been thinking about actually very recently, and like how we can improve the design. And one of the issues that we're thinking of is like this instability of the next epoch look ahead. What does this mean? So like the problem here is that the L1 proposers are elected based on effective balances. So like how much they are staking basically. And the thing is that this can change at the epoch boundary. So during the epoch, the EB is like fixed. They're not changed. But when the epoch changes, it can change. And how it can change, for example, like if the proposers that are like in the next epochs, like look ahead, for example, if they're slashed, their EB will decrease. And if their EB decreases, like they can be like removed from the look ahead. And like all the look ahead is like, one thing note is that all the look ahead is like based on the EB, like the EB amount. And furthermore, like one interesting thing or like thing to consider is that max EB may make this more common. So before, like basically EB changes, it was like effective balance was capped at 32 ETH. So like the only case or the realistic case where the EB will change is like slashing. But now with max EB, they're like more because like it's not capped to 32 ETH anymore. Like for example, you can receive like proposer rewards or like attestation rewards during the previous epoch. And as a result of those rewards, like the next epoch can change, like the look ahead can change. And yeah, we have to look at like how common this will be. And like we're still looking into that, but like there's one potential concern that we have. So it's already the instability of the next epoch look ahead is like already a concern, like right now, like even without max EB because you have slashing, but it might be more common with max EB. Okay, so like here's one example, like yeah, at the epoch boundary, like some like EB change happened, and as a result, this proposer for slot 34 that was in the look ahead in the previous epoch, like it can be switched over to 34 prime. Okay, and yeah, so and note that like this is not only about the on-chain visibility. Like it's not just that the EVM does not know what the next like epoch's look ahead is. It's more like fundamentally impossible to know like the next opted-in proposer before the epoch with 100% certainty. Like, and this both for off-chain and on-chain. So at like thought number 30, like it's fundamentally impossible to know like who, like let's say that these two are non-preconfers, so they know. So when they want to know, when anyone wants to know, and like the preconfirmation ecosystem wants to know who the next preconfer is, like they cannot like reliably know who exactly is going to be the next opted-in proposer in the look ahead because like they only have you can only reliably know the look ahead in the current epoch. The next epoch, it's like it can change. Okay. And yeah, feel free to ask questions anytime actually. And yeah, so this is one of the issues that like we've been recently thinking about. And yeah, so like one solution that we've been like recently thinking of is introducing what we call a epoch bridge preconfer. So the idea is that like the next preconfer here, it's like unreliable, like you can't get it reliably. So like maybe not rely on the look ahead to get the next like preconfer in these boundary cases. So instead of relying on the look ahead, you can rely on what we call epoch bridge preconfer. So what they are is that the first preconfer in a epoch, we assign it to a special or like a epoch bridge preconfer, which is selected via rando. So like you can randomly select from all the opted-in proposers and like select kind of like a fallback mechanism that you have in other like current look ahead solutions, but it's like you can randomly select from the set of like all preconfers. And that this EBP, like this epoch bridge preconfer, they'll be like the first preconfer in that epoch. And so one thing to note is because they're randomly selected and they're like highly unlikely that they will actually be like the L1 proposer in this like duration, like they can't directly force include the pre-conf transactions on the L1. So like you would need some buffer for mempool inclusion. So like here we have some buffer. Instead of having the epoch boundary proposer like here, you put some boundary. So like they can do pre-confirmation duties and they also have some buffer to actually include the transaction that they actually pre-confed. And another thing that they're tasked to do is the epoch bridge preconfer, this preconfer will submit the look ahead of the current epoch and plus the next epoch bridge preconfer at the L1 submission time. So instead of like having the current epoch proposer like post the look ahead of the next epoch, like they post the current epochs like look ahead. So this you can get reliably, like it's the effective balance will not change during like the current slot. So this I will like submit the remaining of the look ahead. Okay, so yeah, these are solutions I've been recently thinking of. And yeah, one thing to note here is that the issue of this instability of the next epoch look ahead is like independent of our POC optimistic look ahead submission design. Like any design will have to like at least consider this. And so yes, it must be considered even considering alternative approaches that we'll also discuss in the next section. Okay, so like, oh yeah, go ahead. Someone raise your hand.
Just a quick comment on this. What about if we just shift the look ahead? So once we bridge into the look ahead boundary into the next epoch, it only becomes so it is active based on what the actual look ahead is, but we always shift it like X number of slots. So it's deterministic.
Okay, so you're saying that here, I think, wait, you shift it and then you add some buffer at the start of the epoch? That
Yeah.
okay. Yeah, like I think one issue there is that like if the proposers do not align with the look ahead anymore, if you shift it, I think that will happen. And then now like the proposers, because like they won't be the proposer for like they might not be the proposer for the allocated like pre-confing slot, and they can't do the force inclusion or like the included in the proposed, like they don't have control over. So yeah, I think that'll be one issue there. Any other comments or suggestions, or yeah, is it very new to us too? Okay, yeah, and that's this part. Yes, and another like, yeah, that's it for like this specific issue. And also wanted to like quickly raise some other discussion points around our POC design, so around the optimistic design that we're having right now. First, like quickly, like we have some optimization that we're newly introducing in our POC design. It's on like So one thing we do is like when you submit the look ahead to the L1, we Merkleize the look ahead. So we only like post the Merkle root of the whole look ahead to the L1. So this like reduces the storage slot to 1, which is great. And one thing you have to do is when querying for the look ahead, you have to like, yeah, provide a Merkle proof. And yeah, this is like in line with, I guess, the URC design too. And another like interesting topic is like in our optimistic POC design, like the Tycho preconfers are tasked to submit the look ahead for the next epoch. And even like in the new design, like it might be the current epoch, but still like the preconfers, you rely on them. And they're incentivized to do so because we condition the L2 block submission to the posting of the look ahead. So if you want to post, like you have to post a look ahead. There's no way around it. And they should be like incentivized to post these L2 blocks because like there's revenue to be made there. However, like the issue here is like you want to make it shared. We cannot just rely on Tycho preconfers, like because like there are going to be a bunch of base rollup, bunch of like other preconfirmation protocols. You don't just rely on one protocol to like have the look ahead visible. And some possible solutions here are like to design a mechanism to incentivize open look ahead submission. So like have something similar optimistic design that we have right now. Just somehow incentivize, add an incentivization mechanism so you don't just rely on Tycho preconfers. But how exactly this will work, I really have no idea. And another alternative could be to consider like alternative look ahead visibility schemes, like not this like optimistic one. And so like some alternatives can be one like calculates the look ahead in the L2 derivation execution, and this is actually exactly what Jason shared. And yeah, I think it's doable. Like I guess the only downside is that you complicate the L2 execution, and which might also like be blocking for like, for example, native rollup integration and all that. And but yeah, it's like potentially very like cost effective. Another like alternative is slightly a little more complicated, but like let multiple L2 block branches to queue up in the inbox based on the block poster. So like at the inbox level, you don't have an if statement saying that you have to be a preconfer because like in the L1, like you just say that you don't know the preconfer at that point when the block has been posted. But later on, retroactively, you know who should have been that proposer for that like specific slot that the submission happened. So you can retroactively like first you can queue up all the blocks that being proposed to the inbox. You can accept from anyone, record like who posted what. Then later retroactively pick like the correct branch based on the beacon root. So like who we're supposed to be that thought proposer. So yeah, it's nice that you don't need like a spread module for like lookup visibility, but the downside is that it requires like at least a 1 slot delay until like that correct branch is confirmed. And finally, as Jason also mentioned, like an EIP for the look ahead in EVM would be, I think, a great addition. Okay, yeah, that's it. I had some slides around how the L2 execution thing could work, but I think Jason covered it, most of it already. So yeah, that's it. Any questions or comments or suggestions?
I guess I can read out loud the question I wrote in chat, but for the epoch bridge preconfer, so maybe the trade-offs here, like by introducing this kind of actor, you're able to guarantee execution, L2 execution preconfs can kind of proceed as usual, but the trade-off is during those slots, you can't guarantee composability with the L1, and then you also can't guarantee that the blob even gets like posted during those slots.
Yes, exactly. I think those two are, yes, completely correct because because like this EBP, they're not the proposer for this slot, so they cannot like have composable things there. But to some extent, this is already happening right now, like because not every slot is like the proposer. Like the pre-confer is not the proposer, but yes, it does like increase that possibility of that happening. And yes, correct for the second point too, like because they're not the proposer, the one proposer, that's why you need this kind of buffer so they have enough time to like, well, stop pre-confing and focus on like inclusion. So they have enough time to actually succeed on the inclusion, because if not, they're going to be slashed.
So one more quick comment on this. I think the other like downside is that the proposers that are at the beginning of the new epoch will basically always be left out, depending on how large the buffer is. So statistically, always disadvantaged if you're at the beginning of an epoch.
Yes, yes, that's true. Yes, like yeah, it's like unlucky if you are a proposer, but you're in this. But in a sense, it's like equally unlucky, so maybe not a huge issue. But yeah, it is true. Any other questions?
Well, I liked the idea with the branching inbox, but is the issue with that like you can't do real-time settlement?
Ah, yes, exactly. Yes, I think that's yeah, I think I think that's the biggest one there. But if we can take that trade-off, I think it's a neat solution.
It's really a shame there's no way to make epochs a sliding overlapping window. Like,
Yeah. Yes, if we had that. Yes.
Pre-register half an epoch before to secure your space within an epoch. And give predictability for a half epoch at a time. It feels like there should be a way to do that, but I can't think how to do it without locking in something in a transaction on chain, which kind of kills the whole thing.
Yeah. And yes, if like the L1 consensus changes, yes, it might be able to make it more friendly to pre-confirm with the print design.
Yeah. It would solve so many things.
Yeah, true.
It almost feels like there's a need with this to not run a pre-confer at the start, like on the first block of an epoch.
Yeah, I mean, well, yes, like that is a possible alternative, but like I would say that UX-wise, it's going to be awkward to have these time frames where there is no pre-confer. And yeah. And because like it's not just about this epoch, it's about like the previous epoch too. So if you have like 10 slots where there's non-pre-confers,
right,
that whole 10 slots you won't have pre-confirmations at all.
So there was a proposal at one point to require pre-confers to honor pre-confers ahead of them with some kind of slashing consequence. I don't remember exactly why that was a thing back then, but I'm wondering if it would apply to this too.
It was like ditch
Yeah.
idea.
Yeah. But I'm feeling like if you did that, then you could have a sort of, you just need to anchor something in the next epoch anywhere, and it would enable pre-confing on the first pre-confer that shows up in that epoch.
Yeah, it might be possible to like have these two slots be pre-confed by like someone, and then say that's the first pre-confer in the next epoch. They have to
They have to
includes in.
right.
Yeah. But still, like the first, yeah, when you, yeah, it is, yeah, maybe doable. Like someone still, yeah, maybe it's doable. Yeah, I'm not sure about trade-offs, but yeah.
I mean that helps with the case where you have like 10 or more slots before the end of the epoch. They're not pre-confers, right? But
Mhm. Yes, yes, yeah.
and there was also so remember originally pre-confers were supposed to get priority within the epoch, but that I don't think that anyone ever figured out how that could happen.
Priority within the epoch.
Like for ordering.
So different priority between the pre-confers?
No, I mean pre-confers were supposed to have priority over non-pre-confers within the epoch, but I think that like was just a thing that was being floated around on the Telegram discussion for a little while, and nobody could come up with a practical solution for making it happen.
Mhm.
Um, that was 6 months ago or more, so I don't.
Okay. Yeah.
Was it to actually put the pre-confirmation on top of the block, or was it to actually give the like earlier
No, it was to put
epoch
the pre-confers on the top of the epoch somehow.
Okay.
But I do
Mhm.
not remember the details of the discussion even anymore. There was a reason for it, and I'm blanking on what it is now. But I remember thinking that it created problems on the tail anyway, so
Yeah, I think like any solutions where you kind of have to decouple the pre-confers from the actual L1 slot proposers, it's gonna cause some
yeah.
like complication when on the forced inclusion because like you don't control those slots anymore.
Right. It's just right after the epoch boundary gets so messy.
Yes, yes, yeah. Any other questions or comments?
And one possible solution, by the way, thank you for bringing this up. One possible solution would be to change how we sample the L1 proposers, and basically instead of just having the current epoch, have multiple epochs of sampling ahead of time. And so if there's any slashing or consolidation, then it doesn't really affect things.
Oh, so this is like a L1 consensus change.
Yeah, but then the question becomes like, how big is the diff? And if it's a one-line change or something, then it might be an easy L1 change to push upstream.
Yeah, I mean, yeah, I think that would be ideal. Like I was kind of like removing that possibility because I assumed it's gonna take like years, but yes.
Well, we have this new kind of desire to do 2 forks per year. So maybe like towards the second half of 2025, we may be able to push it in if it's literally just a one-line change.
Okay, cool. Okay. Yeah, then I think it's worth like thinking about it. Yeah, because I really haven't talked about it. But yeah, thanks for bringing that up. Any other comments or questions?
I mean, I haven't looked into the consolidation EAP, but like one thing we could do is basically, I mean, maybe it's too late now, but we could basically delay the consolidation to the epoch boundary, basically sample the L1 proposers before doing the consolidation, so it doesn't affect the next result.
Yeah.
Okay, so yeah, I see. So right now, like the consolidation is done, I think at the boundary. Are you saying that you do it before, like maybe
Oh, if
the
it's done at the
previous epoch
boundary, then
boundary?
it's great because all that needs to be done is basically sample I guess, before doing the consolidation instead of the other way around.
Okay. Oh, okay, I see. Oh, yeah, yes. Okay. Yeah, then yeah, it might be like a few line change, yes, if that's all needed. Yeah. But actually, yeah. So you're saying that like you sample, determine look ahead, and then like do the max EB changes.
Yeah, exactly. Yes.
Yeah, okay. I see. Yeah, that might be like
And
just switching around some code, yeah. Might be
if it's
simple.
literally like switching 2 lines of code, then that's something. If we inform ACD like as soon as possible, then it might be a last minute change we can push in. I don't know.
Okay, wow. Okay, yeah. That's interesting. Okay, yeah, we can take a look. Yes, hopefully it's that simple, but yeah, to be honest, I'm not sure. Any other? We're pretty beyond the time.
Yeah, I just want to say next time, I think maybe Lynn, we should get together and do a joint talk about the blob
Oh yeah.
aggregation and
Yeah.
both.
Yes,
I think
yes.
both you, Neithermind and Spire, have found a lot of things in our development of a prototype for this that
And I think Open Zeppelin has done quite a bit of work too. And this will be like the top of the list for next meeting. So it'd be good to get all three perspectives and, did we identify the same challenges, problems, things like that. So
yeah.
Yep. Yeah, it sounds perfect.
Yeah. We do have a little bit more than the proof of concept that we launched before now. So we've actually got on a test net full like aggregated blobs posting with we're finishing up the contract integration for it, but minimal on-chain costs. So it's progressing, but we're running into a lot of issues, especially around guaranteed or confidence of getting it on chain on a given block. So
nice. We'll have it top of the list.
Nice.
I guess Lynn and Connor, have you talked with anyone that's working on the Max EB, like to get all the nitty-gritty details?
Actually, no, we haven't.
Just been reading. That's the other thing we could do is maybe get just a smaller call next week for everyone wants to join, and that person could talk about some of this, and we could work through it.
Yeah, yes, I mean, yeah, if you can talk with someone knowledgeable about this, it'll be great, I think. Yeah.
Let me try to get that done. And I'll just post a link and people can join.
Oh, nice. That's great. Thanks.
Okay, awesome. That was it. Thank you, everyone. We'll schedule a call in 2 weeks.
Thanks.
Thanks. Bye.
Bye.
Thanks a lot.
Thanks.
Bye.
Bye.